can see I'm clearly not at home. I'm actually in Toronto for the week. I don't know if this bike in my hotel room in the background gave it away. Is Toronto famous for bikes? I don't know. I am here for a conference called the Astronomy Conference series. It's a conference series that I absolutely love, and I've actually organised one in Oxford myself before, and it's all about astronomy online. So whether that is education or teaching or research or even outreach like this, where I'm talking to people online about astronomy, it sort of comes under all those headers at this conference. So it's a really exciting conference. It's a conference where we actually have discussions about what the conference participants want to talk about, like nothing's scheduled. It's called Unconference. We also have a hack day as well, where we make tools really quickly together, which is always good fun because you've got so much expertise in the room. Today, I am giving a talk, which I'm quite excited about. I've never given this talk before. It's called, well, the title that I have been given is Astronomy in the Era of Clickbait, which I think is really interesting. So I'm drawing on my experiences with talking to you guys on YouTube about how best to get people to engage and to click on a video. Like, what is it that makes people click? And how we have to be really careful not to over-sensationalize science, because then that can damage science further down the line as well. So I'm really excited to see how people receive it, and excited to see some friends that I haven't seen in a long time as well. And I'm actually going to be speaking to the conference participants all this week as well about what they think we should be talking about online, and what they think the media, whether that's traditional media or social media, just don't talk about enough. So I think it's going to be a good week. First of all, I have to somehow walk to the conference venue in the pouring rain outside right now. It's a good view, but it's also really, really rainy. What do you think is an area of astronomy that isn't talked about enough, or a result that's not talked about enough, or a thing that's currently not known that's not talked about enough? So, as part of my life as a YouTuber, because I can say that now, I'm filming this right now. Hi, future me. She'll hate me because she'll be editing at some point and she'll hate it. But I'm going to be vlogging this whole conference, and I want to come around and ask people that question. What part of astronomy do you wish was covered in the media? Traditional, social, etc. So one of the benefits of being in academia means that you have friends everywhere in the world, including, for me, in Toronto, a friend that works at Google. So I am on my way to Google for breakfast, like you do. Okay, so it's currently the middle of the day. It's like 20 to 4 on the third day of the conference? Yeah, the third day of the conference. Today is hack day. And hack day does not mean that we're like trying to hack government servers or anything. It basically means we're trying to make something really cool in a very short space of time in a very messy way. So we came up with this idea yesterday at the drinks reception where we said, if when you die, your soul gets locked in galactic-centric coordinates, as the sun is traveling around the center of the galaxy, like you stay in the position where you die, and that is true of all humans, animals, dinosaurs, single cellular organisms, then what are we currently traveling through on the sun's orbit around the center of the Milky Way? And so we're trying to work out, from the speed that the sun is going around the center of the Milky Way, like how many orbits ago did the dinosaurs die, or did Whitney Houston die? It's what we're using as like markers, and we're trying to create this really cool 3D render of positions of stars in the Milky Way using the Gaia data, get a really cool model up, and then allow someone to sort of put a date in and work out where the sun was at that time and sort of rewind back through a lot of human history. So I've been taking the Gaia positions of stars and trying to get them in sort of like the right coordinates that we need and give them the right color in terms of like scale. We've had other people scraping the web for like all sorts of like dates and details for like continents and everything like that. Like you've been sorting out like the distance to Whitney. Yeah, you've been working out the speed and how far we've gone around the galaxy in a certain amount of time and everything as well. So it's a lot of coding in like Python, and then also like JavaScript is going on in this corner that you can't see, and we're just leaving that to them because that's well beyond what I can do. And like all the rendering and modeling. We've got a lot of stuff going on in like HTML probably eventually as well to make this kind of like a little web app. So it's really, really cool. And I'm going to go around the conference and just sort of ask people to describe what they're up to now, so what hacks they're doing, because this is kind of really exciting stuff.
And so what we're working on now is we are editing the Wikipedia, we are hacking the Wikipedia, and we've added about 5 biographies of Canadian female astronomers.
When there's an area of Wikipedia that's poorly represented, like women scientists, it's really important to create those pages so that when kids are doing high school or elementary school projects, they can find heroes and role models and people who inspire them and learn about stories of people who maybe they think, that reminds me of me, I could be that person.
And we're also working on some other pages. For example, I just updated a page on the Great Annihilator, and so now it actually makes sense. Right next to this black hole, there are electrons, and the antimatter friend of an electron, the positrons. So these electrons and positrons are annihilating each other and producing all sorts of gamma rays, and that's why they call it the Great Annihilator.
Oh, I'm hanging on a few things. So I'm always a bit in love with these things called Markov chains, where it just you kind of chain together the likelihood of 2 words going together. If you train it with a bunch of text, and then you end up getting almost gibberish answers back. So we've been merging together things like the lyrics of RuPaul songs with astronomical terms, for example, which is fierce. We've also been doing things like training it to write abstracts in the same way, and one of my favorite things has been clickbait news articles. So we take clickbait news articles about astronomy, and then we're trying to synthesize new ones, and they're pretty hilarious.
You want to read us some examples?
Can I read you some examples?
Please read us some examples of clickbait astronomy titles.
What's the stickiest object in the Solar Observatory in New Mexico? This tube might be pointing directly at us.
Dun, dun, dun.
What will happen to your brain?
Just what will happen to your brain? Question mark. Nothing else. No.
I think my favorite is slightly bleak. It just says, Japanese scientists say they are not enough.
Japanese.
Yeah. So, but I like these because they're based on real data, and you sort of synthesize them into these crazy, almost real sentences. That's quite fun, and it's really actually very easy to do now.
So today I have written a hack to translate astronomy paper titles into pirate English, because our preprint server, where we host all of our publications before they get accepted to journals, is called the Archive. So I'm creating a new site called the Archive.
This is
and
my favorite thing ever.
It also is a Twitter bot, so it'll tweet out pirated English versions of paper titles.
I'm sure everyone will want to follow that Twitter bot now.
So Archive is a website that was originally started by Cornell to keep track of all the papers that get posted from day to day in the field. And what I'm doing is I'm downloading the names, the authors, and the abstract. So the abstract is a summary of a paper of well, essentially all the papers that got published in a given field. So if I look at galaxy evolution, there's roughly 38,000 papers that are on archive. So I download all of them, and then I make a neural network learn associations between the abstracts of all of these papers, so that if I give it a particular abstract or a title, it can tell me what papers are most related to it.
That's so cool. That's going to be so helpful to so many people in the field.
So today I am building an astronomy acronym generator. So I am training a Markov chain off of a list of astronomy acronyms that I pulled off of Wikipedia. At the moment, I can throw in any known acronym and it will give me random words that it thinks belong after it. But I'm currently working on something that will find the closest acronym to a word and then generate it, so I can start with any word. But right now, I've tested NASA. It's come up with National Bureau of Standards and Technology.
Oh, okay. Nice.
Starts off good.
Yeah. I guess we should explain that, like, acronyms in astronomy is this big thing where they've sort of been done to death and they've been ruined, right?
Oh, yes, very much so. And most of them are very forced, and people usually start with the word they want and just find how they can get the right letters in there, or just ignore them altogether.
Nice.
All right, so earlier I was making some Wikipedia entries for a bunch of Canadian astronomers, which is great. But now I'm trying to use Dialogflow, which is the kind of thing that Google uses to create verbal checks that you can do. So for example, if you ask, what is the weather to your Google Home, this is what the kind of workflow that Google uses. And I'm trying to write one so that I can ask, what are the papers on the archive today? And it can return me the titles of the papers on the archive. As an excuse, really, to learn how Dialogflow works. The problem is, I don't know how Dialogflow works because they use a lot of jargon in their help. And so most of what I've been doing for the last hour is bashing against jargon, but I will figure it out.
But I guess that shows how a lot of astronomers work, right? Is that when we get stuck, the first thing we do probably is go Google and Stack Overflow and try to figure it out. It's the same thing that's happening in these hacks. So
Yeah.
This is how everybody learns a new tool, from Dialogflow to, like fitting a spectral template.
Exactly. You try the simplest thing that is not obviously wrong, and then it breaks, and then you figure out, how do I make it not break, even in a simple case, and then I make it more and more complex. So that's what I'm doing.
So we've been taking this idea, so the Large Synoptic Survey Telescope is going to discover something like 10 million new things in the sky at night. And so how do we try and visualize that? Or more interestingly, is there a way that it doesn't need to be visualized at all, and instead we can use sound as a way to explore the discoveries that are happening every night? And so what I was working on was trying to understand what kinds of objects are we going to expect to see, and how can we assign tones to different classes of objects so we can listen to what happened in the universe the night before.
That's amazing.
Yeah.
That's so cool.
So it's definitely still early days, but I'm excited about the idea.
Nice. So when will the LSST come online? Like, when are we preparing for?
Yeah, so I think first light is supposed to be in October 2022, but that's, astronomers want to make sure all their instruments are working and everything, and the first data release will be something like a year after that.
Cool. Yeah. Fail to prepare, prepare to fail. Right?
Exactly. Yeah.
This looks really exciting. This looks really legit with the board and everything. So, what are you guys hacking on?
So we're trying to think about ways that we as astrophysicists can contribute to our choices when we're designing conferences and going to conferences. How can we minimize our impact on the environment? So, yes.
So right now our scope is sort of limited. We're mostly looking at air travel, which there's reason to think that's a major contributor to climate change. Like if we have a conference in Chicago versus Hawaii, we want to figure out how much of a difference that actually makes in what the carbon footprint of a big conference is.
Okay, and then actions we can take, is that the idea?
Yeah.
Absolutely.
Well, one of the major goals is twofold. One is on the conference side to try and figure out how much conferences should be either increasing their price in order to account for these carbon offsets, or perhaps suggesting that people request from their institutions. And then on the flip side, for people planning to go to conferences, rather than the average price, you look at every conference you're going to and you get a better sense of what especially the environmental externalities are, how much you should actually be accounting for all your travel.
So how are you actually going to estimate what the footprint is of a conference? How are you guys actually doing that? Because we can speculate all day, but how are you getting at that information?
math.
Yes.
It's a lot of math. I think so for flights, it's sort of easy because it's been pretty well studied. So there are models that are built to essentially, like, if I'm a passenger in economy class going from New York to LA, like, it's just the distance and the class that you travel in tells you how much the carbon emissions are going to be due to your being on that flight.
Yeah.
The other stuff that Catalina is working on, maybe she can say a little bit. Yeah.
Hotels, okay.
Are a bit more difficult because there's, to start with, I don't find consistent numbers with how much energy are we consuming if we're staying one night at a hotel. So I've seen there's a factor of 5 different.
Okay, so the end goal is, number 1, to have an interactive app that basically lets conference planners to plan where to have a meeting and to suggest how much carbon offset each conference attendee pays. For individuals, you can also use this to plan out how much carbon offset you should contribute when you attend conferences.
What I envisage in the future, once more people start to see this as an issue, is that the department chair each year will allocate a certain number of tons to each professor and a certain number of tons to each PhD student, and that within the department you can trade. So a student can say, look,
cap and trade.
a student can say to another student, look, I really want to go to this conference. I will teach like your TA class for the next 3 months if you give me 2 tons.
Yes.
And professors as well. And that way professors who don't want to travel can hand off their tons.
But that's a really interesting idea, like a carbon budget for a department themselves.
Well, we have a dollar budget, right?
Well, exactly. Yeah.
Something we don't talk about enough is the fact that we currently have no instruments that are capable of finding planets like the Earth. So all these articles you hear about the most Earth-like planet, the nearest Earth-like planet, the most habitable Earth-like planet, they're actually not anything like the Earth yet. We don't have anything that could find an Earth-like planet that's operating right now. So I wish that the media understood that all of these most Earth-like claims, they're not Earth-like at all.
So I work in a planetarium, and I often get people who have heard from the media that we've discovered like Earth 2.0, or like we found oceans of water on another planet. And I think that there's an element of nuance that gets lost between the academic paper that's published and the journalist who writes about it, and then the other journalists that use that paper to basically write their own papers and publish it in their own publications. And so I think that on the scientist side, perhaps we need to do a better job of communicating with journalists and being upfront about what does our science indicate. Just because you found water vapor in the upper atmosphere doesn't mean that it's habitable, and what does habitable zone really mean in the first place?
I think the media does not recognize that most of astronomy is done with enormous collaborations of people and is not really done by just a tiny group. I also wish that the media talked about stars more often because they're great. You gotta know about the stars to know about the planets.
So something that I wish the media would focus a wee bit more on is, most people would probably assume that we have, an amazing understanding of how stars work. And this is not the case. We know the very minimum of the basics, but we don't know things about how much elements each star produces. We don't know things about the mixing inside of stars, which is very important. We don't know, even about our own star, the sun, we don't know how the solar winds work. That's why we're sending out the Parker probe. But even more important things, we're carbon-based life forms that breathe oxygen, and one of the big problems in nuclear astrophysics is we don't fully understand how that reaction of carbon-12 to oxygen-16 works. It should be a really easy reaction to make, but it's one of the last mysteries that we're sort of missing, along with lots of other nuclear physics data.
One thing I don't think that the media and science communication talks much about is the fact that we don't really understand what our own home, the Milky Way, looks like. Any picture you've ever seen of our galaxy is an artist's conception, and that's informed by some scientific truth, but really there's a lot out there that's uncertain that we don't know. So this is a story that's continuing. We are learning new things about our home galaxy, the Milky Way, every year, and I'm happy to be part of that story.
One of the things that I hate is that we only are really encouraged to give press releases when we have something brand new, a result that changes everything. Whereas a lot of the time we're either building a new telescope to do something cool, which is a slow process, or we're like forecasting what it might do, which again is super important and interesting, but we haven't yet discovered the new kind of dark matter or changed our understanding of dark energy. So the incrementalism of science is lost, and I think that that's part of the story we should care about.
I've been thinking about this a lot because growing up I knew astronomy was a thing that one did, or a thing that like humanity held knowledge about, but it always felt so abstract that I actually didn't even realize until college that you could do astronomy for a career. So literally up until like the first month of college, I was like, what would you do with that if you were an astronomy major, you know? And so I feel like something that the media could focus on a little bit more is not only we have this knowledge, but you can figure out this knowledge as a career that people do, you know?
You can get paid to figure out the answer.
Exactly.
The kind of the big problem is that it's not science isn't portrayed as an iterative process. Everyone expects it to be, someone makes a discovery and it's just this big leap in the field, but you often spend years working on just making a very small change in the field, and also there's so many failures along the way. That we learn more from our failures than we do our successes.
Yeah.
I think the media could do a better job of getting across the sort of beauty of not knowing things. So astronomers are often baffled, according to the media, of some new discovery that sort of questions their normal beliefs. But that's the whole point of doing science to me, right? The beauty of not knowing a thing and finding out that, oh, that's a new step, a new thing we can learn.
Myself being from South Africa, I think that the whole of Africa tends to be a little bit absent from the mainstream media in terms of science, and really promoting science in Africa is something that I'm really for.
I think when I think about science media, I feel like a lot of it is very Eurocentric, so I think it would be great to see more popular articles that are written by people outside the US and outside of Europe. Of course I am in the US, so maybe that also affects what I'm seeing, but I just think it would be nice to see more scientists from other countries.
I think that they don't talk about enough how weird the universe is, right? Like, I see a news article and this planet is just like Tatooine. No, this planet is much weirder than Tatooine. It's orbiting like a pair of binary stars, and there's a third star all the way out, and George Lucas was not quite clever enough to think that up.
That's amazing. Yeah, it's almost the assumption that we should be able to understand everything, immediately.
Exactly.
Or that we should have been able to think of everything that there could be or should be in the universe. But the universe is way smarter than everybody.
And it completely surprises us all the time.
I think the media could also address the fact that how alone the sun is in the galaxy right now. We assume that it started in a stellar cluster, like a nebula of some kind, and that it had lots of companions and friends, but now there's not anything that's very close and not anything that's coming very close. It's just space is just really empty, and it's kind of depressing on how empty it is when you're trying to get that across. The fact that we got to see Pluto and then something else, we're not going to get to see anything else in the Kuiper belt. It's just too empty. It's just too far apart.
I want to pick up on something you just said. It was almost that expectation that when once New Horizons went past Pluto, we were obviously going to visit something in the Kuiper belt because we would be going through it.
Right.
And why wouldn't we? And of course that was something you would do next, when in fact that was actually really difficult.
Yeah.
And that wasn't a given, right? That was sort of a bonus that very intelligent minds managed to figure out.
Yeah, and they did manage to find something that they hoped would be kind of there, and then also one that they were hoping could be there, 2 that it happened to be there, and then 3 that they actually had enough delta V to pass by it.
Okay, so the conference is wrapping up now, and I've had an amazing week, if not a very tiring week, just talking about lots of different things, about how we can do more outreach than inreach, i.e. reach the people that wouldn't necessarily think that an astronomy event was for them when it is. Like, anyone can do it. Best practices for doing research better, best ways of coding differently as well. Lots of different cool hacks that were made this week too. But I guess it falls to me to say what I think the media, both traditional and people on social media like myself, should do better. And I think that it's that we don't talk enough about what we don't know. Like, there's this weird human thing where we don't want to admit we don't know something, when the things we don't know in science are actually the fun bits, and it's the reason we all have a job as well. When we talk about what research we do, we kind of want to talk about it like we know these things, but actually we don't really. You know, we have some idea and we have a little bit of the picture, but in fact there's still so much more to do. And I think when science results hit the traditional news media or hit YouTube as videos, it's all presented as if it's kind of a done and dusted topic, and that discovery or result is the end of the equation or the end of the discussion, and it really, really isn't. If anything, it just sparks more and more questions, and that's where I think, at least, astronomy is most exciting.